Welcome to our first, what we hope will be a long and informative series of Ask Me Anything Abouts here at Platform 9. I'm doing Ask Me Anything About Kubernetes Resource Management today. My name is Joe Thompson. He's not on video, but I also want to give a welcome to my co-host and moderator, Kamesh. And we'll get started here in a minute. I just want to get started with a couple of slides just to kind of set the scene for what we're doing here today. And then if anybody has questions, we'll take questions from the audience, or I can go into detail about some of the things that I covered in the slides in more depth. So, like I said, this is Ask Me Anything About Kubernetes Resource Management. That's a fairly broad topic. Let me just get a little bit of scene setting going on here. Like I said, I'm Joe Thompson. I'm a technical platform marketing or product marketing manager for Platform 9. I've been in IT for almost 30 years. Basically, the end of this year will be like 30, depending on how you count. I've been working in the cloud native ecosystem since about 2014. That's when I first ran across OpenStack. I picked up Kubernetes not too long after that. And I've pretty much been working directly in that cloud native ecosystem, and particularly with Kubernetes, pretty much ever since. So let's talk about resource management and your Kubernetes pods. It's real simple. Your pods have containers. Your containers have minimums and maximums. Kubernetes calls them requests and limits for CPU and memory. There are a few other things. You can do custom resources, but that's a little out of scope. Your pods get scheduled where they can get at least the minimum amount of resources they request. And that pod resource configuration is immutable. The only way to change that is to terminate that pod and then restart a new pod with the updated resource settings. So real simple. Until it gets complicated, it's not as simple as it looks at first glance. When you start digging into this, one of the first things you find out is that your resource requests and limits and how they're set in relation to each other and which resources they are set on then determine what's called a quality of service class. And you don't have direct control over that. But QoS controls things like when your nodes come under resource pressure and pods need to be evicted, how soon does that pod get evicted? And there are some other sidebar things like you can only use static CPU allocations if you have the correct QoS class on your pod, and you only get the correct QoS class if you change your requests and limits to determine that QoS. Then pods can also have a priority, and that's a totally different thing than QoS. And that actually will allow a pod waiting to be scheduled to override another pod. In other words, Kubernetes will say to the node running a lower priority pod, evict that pod, terminate it, make room for this one, maybe more than one, right? And then the higher priority pod can get scheduled on that node. And then as you start digging further and further into it, it starts to get really complicated because sometimes priority doesn't work. Your lower priority pods don't actually get evicted like you thought they were going to be because of other constraints like affinity. And depending on how many questions we get, I'll talk about some of the particular scenarios around that. The other thing that's happening right now is resource configuration is no longer immutable like it used to be. There's an alpha feature, I think it went in Kubernetes 127 or 128. It's still alpha in the latest release, where you can actually resize pod resources in place. You can change the limits and the requests within certain parameters. And you can't do certain things. It's not 100% straightforward, allowing you to do arbitrary pod resizes. But that's a significant deviation from the previous circumstance where pods were just immutable, period, end of story. And then, of course, in any case like this, where we have a complicated situation, especially something that's complicated under the surface, even though it looks simple on top, there's a whole ecosystem of tools to deal with this. It seems like there's a new autoscaler out there every day. The cluster autoscaler is kind of the granddaddy of them all, but there's also others that do things slightly differently, like Kata and Carpenter. The vertical pod autoscaler has been around for quite a while too. There are other pod autoscalers, pod resizers, if you will, and even some commercial products that do things like everybody's got an AI tool now. And so there are a lot of startups that are applying AI to pod resizing to try to get your, pod request efficiency. So looks like we have our first question. How is Carpenter different from a cluster autoscaler? Well, it is a cluster autoscaler. It's different from the cluster autoscaler, the one that the Kubernetes project maintains, in that it uses different mechanics. So one of the main things about the default Kubernetes cluster autoscaler is it manages a node group. It manages an auto-scaling group in your cloud provider of choice. And so what it's doing when it auto-scales your cluster is it's saying, add one to this node group that already exists. Now, creating all those node groups can be a little bit of an administrative hassle, because if you want to have nodes of different sizes available to auto-scale, you have to have a node group that uses those different node sizes. So setting up node groups for every different particular combination of CPU and memory and et cetera, you get these proliferating node group configurations in the cluster autoscaler. What Carpenter does is it skips all that and it says, all right, what I'm going to do is I'm going to look at the pods that need to schedule right now. And then I'm going to provision a node, not scale up a node group. I'm just going to straight up provision a node that is the appropriate size to let that pod schedule. And right now, the only official integration that Carpenter has is with EKS. That's another big difference. The default default cluster autoscaler, because it's been around for a long time, almost from the beginning of the project, it supports dozens and dozens of different cloud providers. And right now, officially, Carpenter only supports one. I do know that there is some sort of integration within Azure to allow Carpenter to be used with AKS. I don't really know all the details on that, but that's not an official upstream integration. As far as I know, the only official upstream integration is with EKS. So what Carpenter does is it just provisions a node of the exact appropriate size for those unscheduled pods, joins it to your EKS cluster, your pod schedules, and then you go on about your day. So that's really the two big differences. Is number one, the mechanics of how Carpenter provisions that node, and number two, what cloud providers Carpenter supports versus the cluster autoscaler. Oh, that's a good one. Somebody said how to decide vertical versus horizontal autoscaling. Vertical autoscaling on the node level, you can do it. I think in most cases, rather than vertically scale a node, it oftentimes is actually easier to just provision a new node of the appropriate size, migrate your workloads over to it, and then terminate the smaller or larger node that you no longer need. And in fact, that's what Carpenter does, is it will actually try to consolidate workloads and say, all right, we don't have that much going on in the cluster right now. We've got all these big nodes with lots of empty space. We can consolidate down. And so it will do horizontal scaling rather than vertical scaling. It does not try to live resize a node within AWS. Now, when you're talking about pods, this is where you start to get into, it's very easy to horizontally scale pods, right? You can always just bump up the replica count in your deployment and a new pod will get scheduled, and hopefully it will actually have enough resources to start on a node. Vertical scaling of pods right now this is where that in-place pod resizing comes into play. Vertical scaling of pods, if you're not using the alpha in-place resize feature, is a disruptive action, because the only way you can vertically scale a pod without that is to terminate it and start a new pod with the new resource allocations. So that is one of those things that the Kubernetes project, way back in its history when it first started, it was all about running infrastructure the way Google did. Everything was kind of a flat, identical plane of compute. There were no differences between nodes. Every workload was cloud native and could tolerate disruption. et cetera, et cetera. Out in the real world, people want to run workloads that can't tolerate disruption. They can't just go, oh, okay, we need to scale that pod up. We're going to terminate it and let it come back up. That can be disruptive. That can actually take something down. It can cause that application to no longer come up properly if it didn't properly terminate. And so that's where the in-place pod resizing has become a priority over the last few releases, where they're saying we need a way to allow people to give their pods more or less resources or increase or decrease their limits without needing to stop the pod completely, terminate that application, and respawn it, because that may not be safe to do. All right. So now let me talk a little bit too about, I mentioned before that sometimes priority doesn't work. And so let me dig into priority a little bit more. So priority is essentially, it's kind of an override button, right? It says, all right, I know these nodes are chock full of pods and there's no place for this pod to run normally. But what I want to do, this pod is more important, and I want to have other pods shoved out of the way to make room for it. So you give it a higher priority, and the priority goes positive or negative, which, if you're familiar with Linux process niceness from way back in the day, you can have negative nice values where it trends more and more toward that process only runs during idle time, or you can have positive niceness values where the system says, all right, that's a high priority process. I'm going to hold other things for this one. Pod priority is kind of the same way. There's negative priorities, which means that pod will, essentially be moved out of the way for anything. And then there's positive priorities, which say this pod moves other things out of its way. So in theory, if you give a pod, the default priority is 0. So in theory, if you give a pod a positive priority, 10, 50, it goes up into the millions, that pod then will be allowed to shove other pods out of its way so that it can schedule. But there's a weird little caveat there. The way that Kubernetes determines whether a pod can schedule, the way that Kubernetes determines whether pods will be evicted to allow a higher priority pod to schedule is, the calculation it does is, if I evict all the lower priority pods on this node, can I then schedule the higher priority pod on that node? Now, if all we were talking about was resource limits and allocations, that would pretty much automatically be true. But in Kubernetes, you also have things like affinity. And so you can actually have a situation where a higher priority pod has an affinity with a lower priority pod. And therefore, if that pod needs to evict the lower priority pod that it has an affinity with, it won't schedule, even if there are theoretically other pods that could be evicted, because with Kubernetes, it's all or nothing. The calculation is, if I evict all lower priority pods, it doesn't try to figure out which ones it can or can't based on anything else. So you can actually, because of the affinity rules, you can have a lower priority pod block a higher priority pod from scheduling in some cases. It's really weird, and it sounds like the kind of thing that you wouldn't run into too much. But I have seen multiple cases where people said, my high priority pod's not scheduling, what's going on? And then come to find out there's pod affinity or there's node affinity or something like that. So you get those kinds of things where there are these additional complications outside of just the priority, just the resource allocation, just the resource limits. The other thing I want to talk about a little bit is, I've mentioned eviction, and I've mentioned with priority, it's actually called preemption. And those are two different things. So with preemption, preemption happens regardless of anything but priority. Okay. Eviction happens based on quality of service class. And these are two separate systems, and they're invoked in different ways. Eviction happens when the kubelet on the node notices that that node is hitting an eviction threshold. And you can configure that. And so the eviction threshold might be 80% of memory is used. Now we're going to start looking for pods that we can evict so that we don't go all the way to the end of, the node is completely utilized and we end up in some kind of allocation storm, right? So Eviction happens managed by the kubelet on that pod based on quality of service class. There are three QoS classes. The lowest one is best effort. Those pods, they may run, they may not. It all depends on whether there's available resources anywhere to run them. Then you get burstable. Burstable pods, they run based on their allocation. They have an allocation that is lower than their limit. Well, let me back up. Best effort pods have no requests, right? They have no requests and they have no limits, because if you have a limit without a request, then your request is set to the same as the limit automatically. See that I told you this is getting complicated. So best effort pods have no requests, no limits. Burstable pods have a request. They don't have a limit. And so they will get scheduled if there's enough resources, and they will be allowed, or excuse me, they may have a limit, but it's a limit that is higher than their request. So they're kind of allowed to live in that space between their minimum and their maximum. Guaranteed pods have a limit and a request that are identical. And there's some fairly strict criteria there. To be guaranteed, you have to have a limit and a request set on every resource, and those limits have to be identical. And then once you're guaranteed, that makes you the last pods to get evicted. So eviction starts with the best efforts. Then if the best efforts all get evicted and we're still under resource pressure, we start evicting the burstables. If all the burstables get evicted and we're still under resource pressure, we will evict those guaranteed pods, but it's kind of a last resort. It's like everything else has been evicted and this is all we can do. Preemption exists outside of that whole, I see the question, I'll get to it in 1 second. Preemption exists outside that whole QoS class eviction paradigm. Preemption is just, do I have a higher priority? Yes, then everything gets evicted and I get scheduled instead. So you can get into these weird conflicts where people think that their guaranteed pod is going to schedule and it doesn't, or think that it's going to survive the scheduling of a higher priority pod because it's guaranteed, and it doesn't. What are the best practices for requests and limits to ensure best resource management? Well, that's literally the $10 million question, right? There are startups around. There are many, many dozens of startups that are just trying to answer this question, right? And there's many, many dozens more that are trying to answer this question as part of their platforms of what they do. Really, it comes down to knowing your application, knowing what your application needs, and knowing kind of what the ups and downs are. So the biggest thing, I think, is to make your application as cloud native as you can. Make your application as tolerant of disruption as you can, because at some point, for some action, you may need to terminate that application, and you want to make sure that it's safe to do that. Once you know what your application's performance is, and especially if your application can tolerate disruption, then you can start looking at things like, do we need to vertically scale our pods? Do we need to horizontally scale these pods? Will this application actually benefit because it's sufficiently, cloud native, shared, nothing, whatever you want to call it, that if we have extra load on it, we can just throw more replicas at it. So we don't need the replicas themselves to change size. We can just add more or remove some depending on the load. Where you really get into nasty stuff with this is, and this is something I've been paying a lot of attention to recently, is Java applications on Kubernetes. And that's because Kubernetes, the kubelet, is essentially running containers on a node, and the node itself is managing memory, CPU, like all of that is actually happening and being managed and throttled and so on through the node's operating system, through those Linux C groups and such that Kubernetes knows how to interact with to set the pod limits and so on. With Java apps, there's an extra layer of abstraction there. And so this is what makes Java apps really hard to manage in terms of requests and limits, because you can have the JVM will pre-allocate resources to itself, will pre-allocate memory to itself based on what it sees as available when it starts up. Now, in the old days, this actually used to be a real pain, because the way that containers in Kubernetes worked up to about 2018, a Java app starting in a container, the JVM actually saw the host memory resources as the size of memory that was available, and it would try to pre-allocate based on that. And most of the time, the container limit was set much lower than that. And so what you would actually end up with is these situations where the JVM would try to start up, it would try to pre-allocate all the memory it thought it should pre-allocate and immediately get out of memory killed. Java is now container aware for about the last 6 or 7 years. So you don't so much have that problem anymore. But what you do have is the problem where the JVM wants to manage memory itself. It doesn't want to let the host do it. And so the JVM still pre-allocates memory to itself, and then it kind of hands that memory out to the running Java code as it needs it. And as the running Java code doesn't need that memory anymore, and those object references get orphaned, eventually the JVM will do what's called a garbage collection sweep. It will go through and it will mark all of the memory that's no longer used. It's objects that don't have any references anymore in the running Java code. It'll mark that memory as available, but it doesn't give it back to the OS. It just kind of gives it back to itself and says, okay, if I need this, if I need to hand this memory out again later, it's already here. I already know I have this much memory free. On some level, that makes sense. If you needed memory once, you're liable to need it again. But it makes Java application resource management in particular a huge pain on Kubernetes, because you've got this extra layer of abstraction that the only control you have over it really is you have to control the Kubernetes resource management. And then you also, inside those containers, you have to separately control the Java resource management. And there are controls for that. There are things like alternative garbage collectors that don't behave in the same way as the default garbage collector of, greedily retaining memory. You can configure the default garbage collector also to return memory to the operating system. It will do it, but only under certain conditions. So that doesn't often move the needle. A lot of people, I ran a poll on this on LinkedIn the other day, and about a third of the respondents were using alternative garbage collectors in Java because of these Java resource management issues. And about another third were running some sort of custom arguments to the default garbage collector. So this is a problem that people have had a lot of with Java in particular. Apps like Spark. Well, so Spark, you have interesting things where I've been playing around with this a little bit myself. I don't have a big data background, so I haven't done a lot of Spark stuff myself. But in looking at this, there's basically two models you can use for Spark. And I ran a poll on this as well. You can, in theory, have your Spark analysis jobs run Spark themselves in their pods. So you can have a local Spark service that another container submits to. And the other model is you can have a centralized Spark service. That's just a Spark cluster essentially running in Kubernetes, and it has different workers. And then your other pods are separate from it, and they submit jobs to it through the service networking. So the difference there is that in the kind of internal model, you have the Spark is running within a single pod with the job submission. And then with the other model, it's running in its own separate set of pods, and the job submission pods are, a separate deployment or a separate, one-off. It could actually be a Kubernetes job for that matter. It could be, let's throw a whole bunch of data analysis requests at the Spark service and wait till they all complete. All right, so let me jump back a couple of slides because there was one thing I wanted to cover. Oh, the other thing about Kubernetes pods that makes them a little bit interesting to resource manage is there's no live migration of pods in Kubernetes. There are kind of some base capabilities now for things like pod checkpointing, right? It is now theoretically possible to you can checkpoint a pod, which is essentially saving an image of that pod to persistent storage. You could then, in theory, take that persistent storage across to another node, and you could restore from it to a new running pod. The reality is there's a lot of stuff that makes that difficult to do yet. I mean, networking is the least of it. The other thing is if that original pod was using a device or using storage that's not available on the new node, what are you going to do? So there's going to be a lot of restrictions for that. But one of the things that would be nice to have is if you have a pod that literally is growing to the point where it can't live on the node anymore. So it's already been scheduled. You gave it a request and a limit. And when it was scheduled, everything was fine, right? In the meantime, as that pod has lived its life, other things around it have been scheduled on that node as well. And they've also grown from their request up toward their limit. And so what you can end up in, and Kubernetes doesn't stop you from doing this, is you can have a situation where if every pod starts to use close to the limit of their requested memory, there won't be enough memory on the node. And so that's where you start getting into resource pressure things, right? That's where eviction comes in. What would be nice is if instead of the pod just getting evicted, if you could say, well, this pod is getting bigger than it used to be, and the node essentially is getting smaller. Let's move it to another node where it can have a little bit more room for its resources. But you can't do that. And so that makes it harder to manage those resources in Kubernetes because you have to be aware when you schedule things that, yeah, we put a limit on this application, but we may be in a situation where if everything uses the full limit of its resource that we gave it, then our nodes, our pods will start getting evicted. So setting the limit can actually backfire on you. So I think we're probably going to go for about another 5 minutes here. I've got some things I can talk about if nobody has any other questions. I think we got some really good questions in this one. Let me jump back one more slide here. I think it's looking at quality of service. Yeah, there was a couple of things that I wanted to cover about quality of service. One of the things that's interesting about quality of service is that idea of, like I said before, you can have your limits can be overcommitted. Essentially, you can have pods assigned to a node that their limits are arbitrarily large, right? I think you are even allowed to schedule pods to a node where the limit is bigger than the total amount of resources available on the node. Because if you ever actually got close to that, that pod would get evicted and it would get rescheduled someplace else. So you have to be careful with your limits. One of the things about limits is if you have a limit assigned, that makes you eligible for eviction earlier than pods that don't have a limit in some cases. So again, this goes back to the idea of everything is very simple on the surface, but then once you start digging down into it, it starts getting more and more complicated. There are all these little twisty turns. It's almost like a little maze of Kubernetes resource management that you have to navigate your way through. And the worst thing about it is you're never really sure if you've gotten to the right endpoint of the maze. All you know is that your things are running right now, today, and will they run tomorrow? If you've done everything right. And the only way to know if you've done everything right is to have absolute and total knowledge of every single thing that is going on in every pod and every node in your cluster. And frankly, that level of knowledge is not something that I think most operators have today. The best ones do, I think, when they have the resources to set up proper monitoring and alerting and that kind of thing, or at least they get an earlier heads up of something might go sideways pretty soon. But I think there's probably a lot of operators out there that are just kind of trucking along and going, all right, everything looks fine today. We're going to keep doing what we're doing and we're going to hope that it stays fine tomorrow. But with resource management stuff like this, it's very easy for it to bite you, tomorrow when you're doing the same thing you were today. So it's a little bit squirrely to get into for the first time. All right, so I think we're going to go ahead. Oh, utilization rates. I mentioned, yeah, my moderators reminding me to talk about utilization rates because that is something I wanted to talk about. We don't have a poll thing on this, so I won't do like show of hands or anything. But I was shocked to find out that, and this is true across multiple surveys, right? Different organizations entirely do these kind of surveys, and they always end up at the same point. most people's utilization is running about 30% in their Kubernetes clusters. And I don't mean that's what they have, you know, actually, that's what they're actually running. In other words, if their cluster has a total of 600 gigs of memory, they're probably using about 200 gigs of it. And the reason for that is because a lot of their apps are out there with resource requests with allocation that they're not actually even using. And so you have all this, it looks fully utilized because your allocations add up to close to the limit of what the cluster can handle, but the actual usage is not anywhere near that. So we're doing a survey on Kubernetes utilization in public cloud. Like I said, we've seen the results of multiple other surveys. We've had these conversations with our customers. They usually come out around the same. We would love to get some additional data from people so that we can kind of see what the pulse is right now. Are people actually doing any better with all these new tools that are coming out, like Carpenter and pod resizing and that kind of thing? Or is it still pretty much 30% across the board? And if you fill out the survey, you can win a prize. The other thing we have is we do have a Slate. We have a community Slack for Platform 9, and we have a Slack channel for these Ask Me Anything Abouts. We would love to see people join that Slack and come in, and either you can maybe ask additional questions if you join and you weren't able to make this live and ask a question. You can ask a follow-up question there, or you can maybe suggest topics for a future AMAA. And just kind of hang out and chat with people, and we'd love to see you join and participate. And I think with that, we're going to go ahead and wrap it up. Thanks everybody that joined. We got some really good questions. Like I said, we'd like to see people continue to participate in our Slack and engage with us on our other social media as well. We have the Platform 9 blog also, where we cover a lot of issues related to this. That's kind of been the latest series of blog posts that I've been writing, have been all about Kubernetes resource management from every angle. So definitely go ahead and check that out as well. Thanks so much, and we'll see you next time.